Welcome to today's webinar, Scaffolds, Hazards on the Construction Site. When OSHA revised its scaffold standards in 1996, the Bureau of Labor Statistics study showed that 25% of workers injured in scaffold accidents had received no scaffold safety training, and 77% of scaffolds were not equipped with guardrails. OSHA estimates that informed employers and workers in compliance with correct safety standards can save as much as 50 lives and prevent 4,500 accidents every year. In a recent Bureau of Labor Statistics study, 72% of workers injured in scaffold accidents attributed the accident either to the planking or support giving way or to the employee slipping or being struck by a falling object. The OSHA standard sets performance criteria to protect employees from scaffold-related
Matt, I'm online, by the way.
hazards such as falls, falling objects, structural instability, electrocution, and overloading. It also addresses training in various types of scaffolds as well as falling objects, protection, ladder, weather conditions, aerial lifts, stilts, and other matters that are not covered in OSHA's previous scaffolding standards. In addition, it allows employers more flexibility when using protective systems for workers on scaffolding. We do have our presenter on the line, so we're going to continue on with our presentation here. During the webinar, our presenter will cover the following: the 3 types of scaffolding, the 4 main hazards to which persons working on scaffolds are exposed, and methods of hazard prevention for each of the hazards, and the 3 essential elements of safe scaffold construction. The webinar will feature David Doddridge. David has over 50,000 hours of hands-on construction, building, inspection, and consultation experience. As an expert, David provides attorneys with expert consultation services in the following areas: personal injury, construction accidents, OSHA, construction defects and damages, building codes, and building inspections. David performs site inspections, expert report writing, and expert testimony. If you have a question that pertains to today's presentation, please use the Q&A feature found on the right-hand side of the screen, or the chat feature also found on the right-hand side of the screen, to submit your questions. David will do his best to answer your questions during the presentation. Tomorrow morning, I will send out an email with a link to the archived recording of the webinar. We do ask that you take time to fill out the survey that will appear on your screen after the webinar is over. I now invite you to sit back, relax, and enjoy. I'm now going to turn it over to our distinguished presenter, David Doddridge. David, it is all yours. And David, I now have the PowerPoint presentation up on the screen with the title slide. So you can begin your presentation, and I'll advance the slides as you go.
Yeah, okay. Good afternoon, everybody. My name is Dave Doddridge, and Matt, by the way, I have the PowerPoint presentation here in front of me as well. So I'll try to flip through these slides simultaneously with you. So here we go. Scaffolds, hazards on the construction site. First of all, I thought we would go through a few basic things about OSHA, what it is and what it does, and certain fundamental requirements that OSHA calls for. OSHA, of course, is Occupational Safety and Health Administration, and they are responsible for worker safety. OSHA basically regulates standards that are in place with regards to the safety of employees, not only on construction sites but in other industries as well, and mandates record keeping and various safety and health standards. Who's covered under the OSHA Act? Most private sector employees. There are OSHA-approved state programs that must meet or exceed what they call federal OSHA. Matt, I'm on slide 5. I'm not sure what slide you're on.
Yep, I'm there as well.
Okay. Yeah, just try to keep up. Okay, so what does OSHA require to determine which standards apply to your workplace? For example, in my industry, 1926 is for the construction industry. There's other OSHA standards that are written for other industries. Worker responsibilities, of course, are to work according to the OSHA regulations, an OSHA poster that's typically posted on the construction site, follow the employer's safety and health rules, safe work practices, cooperate with OSHA inspectors if there's an inspection, which, by the way, they can do without notification. Workers' rights, they have the right to identify and correct problems in the workplace, and they also cannot get fired if, in fact, they register a complaint with OSHA for unsafe workplaces. Employers' rights and responsibilities to provide a safe workplace, of course, and also to provide training, record keeping, and employers have the right to correct deficiencies within a certain period of time after an inspection is done. A lot of times you'll hear reference to a competent person. A competent person would be somebody who's been trained in construction safety, for example, in my industry. They know which standard applies to a particular operation. They have the ability to identify hazards in the operation, and they're also somebody who's designated by the employer to take the appropriate actions. For example, setting up scaffolding, working on the scaffolding, certain components of the scaffolding that must be in place, for example, guardrails, that kind of thing. So a competent person isn't necessarily, an engineer. A competent person is somebody who has received proper training and through experience is able to identify those various hazards and obviously avoid them. So that's just some basic stuff about OSHA. So now we get into scaffolding. I think most of you probably recognize that photograph. So scaffolds. What is a scaffold? There's 3 basic types: supported, suspended, and aerial lift. What you're seeing in the photograph there is a supported scaffold. It's supported by the ground that it's set up upon. Some of the various hazards. Matt, by the way, I'm on slide 13.
Yep, I'm there as well.
Yep, obviously falls caused by slipping or the lack of fall protection, bad planking, that kind of thing. Naturally, scaffold collapse. Electrocution is a big one. Scaffolds are typically made out of metal, and on an existing building, for example, you might have a power line that's running into the building or near the building. So there are certain precautions that need to be taken with regards to the distance that you're working within or outside of a utility line. Struck by is a big one. They call it struck by. You're working below and somebody drops a tool above, and it can hit you and naturally cause severe injury. Typically falls occur while you're climbing on or off the scaffolding. A lot of people will use, you see in this photograph, the red scaffold that's there now. It's got the horizontal bars, and that's not necessarily meant to be used as a ladder. It's perpendicular, it's straight up and down, whereas a ladder is typically on a 4-to-1 ratio. So for every 1 foot out at the base from the building it goes up 4 feet. So it's on an angle. It's much safer to use. Unguarded scaffold platforms, scaffolds that don't have guardrails. Obviously, this picture is not, guy's not working in a safe fashion at all. This happens all the time. You don't have to fall far at all in order to get severely injured. Slide 15 here shows a guy on some ladder jacks painting the end of the house. You know, he's probably a good 15, 16 feet up into the air. He can really get hurt. That is not a safe situation at all. He should either be tied off. If you're over 10 feet, then you need to have fall protection. Fall protection is either via a guardrail that has to meet certain requirements, or what they call personal fall arrest system, which is a harness with a lanyard and it's tied off to an anchorage point. Now here's slide 16, photograph of supported scaffolds. Those are what are called pump jacks. You can raise the scaffold as the work progresses upwards. There is a guardrail there. You'll see the horizontal railing. That has to meet certain requirements with regards to the strength of it. It has to be able to withstand 200 pounds of lateral force. The top rails have to be 38 to 45 inches off the work platform with a mid-rail in between. But you'll notice on this scaffold there's no toe board. If you look down at the bottom of that railing system where the planking is, there's supposed to be a toe board there. And I don't see it in this photograph. The toe board is meant to contain maybe a hammer or a brick or something that could be accidentally kicked by one of the workers and fall over the scaffold. So there needs to be a toe board there to prevent that from happening. Slide 17 shows a good example of personal fall arrest system. You'll see he's in a harness. His right hand is holding a lanyard, and that is attached to the anchorage point above his head. So if anything happens, if he falls, he'll be suspended. He'll be kind of hanging there, but at least he won't come in contact with the ground. PFAS systems require training. It's basic, but people need to be trained in their proper use. So fall protection requirements are, again, either using a personal fall arrest system or PFAS or guardrails in lieu of PFAS. This slide 18 shows the scaffolding. The ends, as it says underneath the photograph, are not properly guarded. There's no guardrail there, so you can walk off the end and fall and get hurt. Falling object protection is naturally a big one, which is why hard hats are required. Barricading the area below the scaffold, using panels or screens. What they mean by that is if they're working on a scaffold and they've got a stack of bricks that are, say, 18 inches tall, but you've only got a toe board that's 3.5 inches tall, then what they should at least do is put a piece of plywood in between the outer edge. It's not shown in this photograph, but in other words, a panel or a screen to heighten the toe board so that it exceeds the height of the pile of bricks or whatever it is that are placed upon the scaffold. Here's a good example in slide 20 of overhead power lines and how closely people can be subjected to working amongst them. Power lines are right in their work area. And a lot of these power lines are not sheathed. So you'll see, and I've seen them on my construction projects before, you'll see power lines that are just bare copper. You can tell the copper turns green, and you can tell there's no rubber sheathing around them. So it's a live wire. And you can have some real problems, obviously. I've had cases with just that, electricity on an unsheathed power line. So if you're driving down the road, sometimes you'll see the orange covers covering the power lines. And naturally those are meant as a temporary sheathing to protect people that are working in close proximity. So I've actually called both public and private utility companies before and have them come out and actually place orange covers on unsheathed power lines in the past because we were using either metal scaffolding or a crane in order to prevent any real hazards. Okay, scaffold supports. You'll see on the left that's an example of good support. It's got the base plate and the mud sill. The mud sill is meant to sort of distribute the weight over a greater area rather than just taking that small metal base plate and setting it on the dirt where it could compress. The mud sill basically distributes the weight over a larger area, prevents that from happening. The photograph on the right, obviously you can see if you take a close look, you've got scaffold supported on, there's no base plates. It's just a round tube that comes down, sets upon a 2x4, setting upon a couple of other 2x4s, and a concrete block. And that scaffold, if it got hit or was subjected to any real lateral force, could easily become displaced. And if anybody's working on it, they could fall off, or maybe a hammer, a tool, or a building material could fall off, strike somebody. Slide 22, essential elements of safe scaffold construction. Obviously using appropriate scaffold construction methods, proper access via ladders. So you can see in this particular slide, in the photograph, on the right-hand side, you can see ladders going from one level to the next. Some people, I've seen them, if you see the diagonal cross bracing, pardon me, on each section of scaffold, they'll actually climb up that in order to get to the next level. And that's obviously certainly not the way to do it. This photograph here shows proper access from one level to the next. And I would imagine to get to that first level elsewhere in this job site here, that there would be a ladder. But you see that there's no guardrails on any of this. Now maybe they're not done setting it up yet, but there should be guardrails on the outer perimeter of this entire setup here, with toe boards, of course. Slide 23. Platforms must be fully planked. In other words, in the photograph there on the left-hand side, the red scaffolding, there's only one plank up on the top. The entire thing needs to be planked, and the gaps cannot be more than 1 inch. It needs to be able to support its weight times 4 times the maximum load. So if it's intended to hold 2 men, plus the weight of the scaffold itself, and you add all that up, multiply by 4, and that's what the support requirements would be, and they have to be at least 18 inches wide. Now that scaffold on the right, around that chimney there, there's like 1 plank on each section. There's lots of things wrong with that picture there. That each section should be fully planked, or not planked at all if it's a section that you're not working on. There's no guardrails. They are probably climbing up the end frame. If you see in the picture on the right, you'll see on the right-hand side of that scaffold, those are called end frames, and you've got the horizontal members there, and sometimes what they'll do is they'll climb up that. And again, as mentioned earlier, it's not the right way to do it. You want to have a ladder properly set up, proper access to the entire scaffold, properly planked in order to be able to work safely. Scaffold platform construction, slide 24. Obviously, no large gaps. Things can fall through. The ends of the planks must rest on separate supports, and they need to overlap by at least 12 inches over the supports. So in other words, the photograph on the right, you can see where the planks are overlapped, but the plank on the left that's sitting upon the plank that's on the right doesn't reach the support. That plank on the left needs to extend beyond the same support that the plank on the right is sitting upon. What can happen is if you put a lot of weight right where those two planks overlap each other, then it can cause, obviously, downward pressure at that point and cause the other end of the plank to lift up, and obviously somebody could fall, or materials could fall and strike somebody working down below. Scaffold platform construction, slide 25. No paint on wood platforms. The reason why that is because not only can paint cause the surface to be slippery, but that's not the primary reason. The primary reason is because paint hides defects. So if you have a defective plank and it's painted, you might not be able to see the defect in that wooden plank. So therefore, you're not allowed to paint wood platforms. Scaffold grade wood, most lumber yards will sell scaffold grade planks. It's stamped, stating that it is a scaffold grade. There's a stamp right on it. Again, it needs to be fully planked. All the pieces need to match and be of the same type. So in other words, if you might have, as a contractor or whatever, you might have 2 or 3 different sets of scaffolds, not necessarily made by the same company. So the parts and pieces that interconnect one section to the next, or the pieces that connects the wheels down at the bottom if you're using wheels, if you mix and match them and they're not meant to go together, then that can potentially cause a hazardous situation. Scaffold height cannot be more than 4 times its width. In fact, it is, and naturally it has to be. That first slide that we saw around the Statue of Liberty, then you need to use, and by the way, once it gets above a certain height, I'll have to check it, and it needs to be designed by an actual structural engineer. But if on smaller construction sites, residential or light commercial construction sites, if it's more than 4 times its width in height, then you have to use guys, which is a guy wire that would come out diagonally from the scaffold. Ties, which tie to the building, actually tie the scaffolding to the building, or braces to stabilize it. Slide number 27. Each end of the platform has to be either restrained by hooks. There are planks that have hooks on the ends that are like a half circle, and they fit over the horizontal support, and they lock the plank to the scaffold. That's not always the case, and when in fact that is not the case, then the plank must extend beyond that horizontal support by at least 6 inches. You can see it says no cleats, so there's nothing holding that plank in place. If that plank that he's standing on slides backwards, which it easily could, then obviously he could fall and really get hurt. Slide 28.
I think we're going to open it up for questions now, David. I think slide 28 for questions.
Actually, if you go beyond 28, Matt, yeah, let's do some questions. There's a few more slides left, but yeah, you're going to have to tell me what people are asking, and I'll answer them as best I can.
So yeah, definitely. We have a question here from Myrna who asks, what if the scaffold your client fell from is not available for inspection? What can an expert witness be able to do for the matter?
Well, that is a good question because obviously construction sites change daily. And that's one of the biggest problems. I've done a lot of construction accident work, and there's nothing to inspect. By the time I get the case, it's, you know, years down the road. So the smartest thing to do is, if possible, hopefully, somebody took photographs immediately. I've got a case in New Jersey where a worker actually fell 13 feet and was killed, not by the fall, but by a window that fell upon him that he was installing. And fortunately, I had a lot of photographs that I could look at. I've got a case in New Jersey at the New Jersey Meadowlands where a gentleman fell 45 feet. And I think I've got one or two pictures. It was a very complicated scaffold system that was set up. And sometimes, to answer the question, as an expert witness, you have to ask what kind of scaffolding was it. You have to try to find out as best you can through the attorney that's hired you, through the guy who was injured, what type of scaffolding was it, what manufacturer, as many facts as you possibly can, and just use your experience to be able to sort of visualize it in your head. And unfortunately, that's about all you can really do.
Okay, great. We have another question here from Jim who asks, what if the guardrails are not in place and the personal fall arrest system is not feasible on the scaffold system?
Then, in a situation like that, the personal fall arrest system would not be feasible. For example, if you're only, 10 or 12 feet from the ground, I mean, the length of the lanyard and the rope that the harness is attached to, you'd hit the ground before the slack was taken up, and you'd be protected. So OSHA does have in its regulations something called a CAZ, which is Controlled Access Zone, and that's intended for that type of scenario when, in fact, there are no guardrails in place, and when a personal fall arrest system is not possible. Controlled Access Zone is controlled by a competent person whose sole job it is to watch the workers, watch for hazards as the work progresses, and until such time as fall protection measures are put in place.
Okay, great. And it looks like we have one more question, and then we can continue on with the presentation of content. We have a question here from Carol who asks, what measures can be undertaken when you have no choice but to work close unprotected or in the proximity of unsheathed power lines?
Well, you should never work within 8 feet of an unsheathed power line. The employer should have them covered by the utility company. And that's just how it is. I mean, I've had situations like that on my construction sites before, and you call the utility company and you do not work in close proximity to those power lines, period. So the answer is you don't. Only work near power lines if it's safe, if they're covered, or if you're far enough away to make sure that you're working safely.
Okay, great. I don't see any other questions in the chat queue or the Q&A queue. So let's continue on with the presentation of content. I have the next slide of 29, supported scaffolds.
Yeah, supported scaffolds, obviously, are scaffolds that are resting upon the ground. They're supported by a number by legs, outrigger beams, poles if you're using pump jacks, frames like the end frames that we discussed earlier. That photograph obviously shows a inadequately supported scaffold, and you see this all the time, especially on residential and small commercial jobs where they don't have safety personnel, where there's not necessarily a competent person there. Perfect example earlier was that gentleman that was on the ladder jacks painting the gable end of that White House that we saw earlier. A lot of times what happens is in residential construction, guys are just sent out to a construction site and told to do something, and they're supplied with a couple of ladders or some scaffolding, and they set it up themselves. They don't necessarily know. They haven't necessarily been trained. So this is a scenario that you see, unfortunately, all too often. People get really hurt. So slide 30, proper scaffold access. Again, the permissible types of access are ladders, like a portable ladder, like an extension ladder, which has to meet certain OSHA regulations, not only with regards to the load that it is rated for, but also with respect to how it's set up, how it's secured, the angle of the ladder, and so on. Stairways, you see these portable stairways that are used, stair towers, ramps, walkways. You can use the building stairs and come out of a window as long as the surface that you're stepping upon when you come out of that window is within 2 feet of the sill of the window. So you're not permitted to climb out a window in order to access scaffolding if the scaffolding is 3 or 4 feet below the bottom of that window. So proper scaffold access is a big one. A lot of people fall just by trying to get to the work platform, not necessarily while working upon the work platform. Scaffold access, no access by cross braces, which I was talking about earlier. See that worker there? He's using the diagonal cross braces to climb up the scaffold, and he's at least 1, 2, 3. He's climbing up onto his 4th section of scaffold, and that scaffold is probably 6.5 feet high. So he's 24, 25 feet up in the air there. Not a good idea. See, when using ladders, the bottom rung of the ladder can't be more than 24 inches high. Naturally, for obvious reasons, because that first step, especially when you're coming down the ladder, if the last rung is too high up off the ground, then you can miss it, you can fall. You can use some end frames. That red photograph there is a picture of an end frame with those horizontal pieces there, and that is sometimes permissible, but only up to a certain height. You can't use an end frame to climb more than the height of that one section of scaffold. It's perpendicular, it's straight up and down. It's not like a ladder. It's a lot more dangerous. All right, suspension scaffolds. These are the kind that window washers use. The photograph here is building maintenance guys. Suspended scaffolds, you always have to be tied off. And tying off means using a personal fall arrest system. So, and the reason being, of course, that if the rope or wire by which the scaffold is hanging, from which the scaffold is hanging, gives way, and you're not wearing a PFAS, then you're going to go down with it. If you're wearing a PFAS on a suspended scaffold, then the anchorage point needs to be connected to something, to a point other than the point that the scaffold suspension ropes are fastened to. So in other words, you're not going to tie off at the same mechanism or the same point that is supporting the suspended scaffold, because again, if it goes, then you go with it. So suspended scaffolds are subjected to stricter regulations, at least in that respect, and also with respect of the load. The suspended scaffold has to be able to support 4 times its intended load. If you read that top line in this slide, 32, it says that it needs to be capable of supporting 6 times the load. Moving scaffolds, oftentimes, painters, plasterers will be using this type of scaffold. And if it's being relocated or moved, then naturally you have to do so safely. So they can't be on it while it's being moved unless the surface is level. It meets a certain height to base ratio of 2 to 1, and you have outriggers. Those wheels at the end of those angled pieces at the bottom are called outriggers, and they basically expand the base width of that scaffold to make it steadier. Slide 34, fatal fact. This is an aerial lift, of course, which is one of the 3 basic types of scaffolds. Ran over a brick, and the sort of extrapolation of the sway of the boom caused the worker to fall 37 feet and resulted in fatality. This picture here on slide 35 just cracks me up. I mean, take a close look at what these guys are doing here. Those are called lean-to, what I call lean-to scaffolds, and basically they're not attached to anything. They're supported by the ground, and they're on an angle, and those horizontal, they're made out of wood. Those horizontal pieces are simply resting against the building, and using the weight, the pressure that's against the building to prevent them from kicking out. So not only do they have that first set, but then they've got a set that's set up on top of those. Apparently that wasn't good enough, so he's standing on the ledge of the building in order to do whatever it is that he's doing. Maybe he's going down to the scaffold, or maybe he's climbing up through the window, but this is really, really unsafe here. That's homemade scaffolding that is absolutely not allowed. The bottom of those scaffolds could easily become displaced and kicked out, and if that happens on one, then the entire thing is coming down. So this is really, really unsafe. Using scaffolds, of course, and we've all seen this in the city, scaffolds that are wrapped with netting. And a lot of this is just common sense. Using tag lines on a swinging load, basically what that means is if a crane, for example, is lifting a load up to the area that you're working in, a tag line is a rope that is fastened to that load, so you can keep it from swinging, and you can control it. Obviously protect suspension ropes from heat and acid, otherwise they can get damaged. Another fatal fact, ice and no guardrails. And here he is, and he slips and he falls, and that's just photograph of, if you see where he's falling there, that's a drawing, of course, but that's where the power comes into the building, so they set up the scaffolding on either side of that power entry point. And in order to get from one section of the scaffold to the other, they simply stuck a plank across. And if it's in the wintertime, you know, obviously things can happen. Overhand bricklaying. This is a picture that we've seen earlier in the presentation. Those are pump jack, what are known as pump jack scaffolds. They are raised as the work continues upward. And in order to access the each course of block that they're installing there, you have to do it from overhand. You're not putting those blocks on at even chest level. You have to be able to look down at the work. So a guardrail or personal fall arrest system is required on all sides of a scaffold such as this, except the side, obviously, where the work is being done. Again, here we see a competent person. I'm assuming in this photograph that the competent person is not the guy underneath the plank. I'm assuming the competent person is the guy pointing his finger wearing the hard hat. But again, a person that is capable, through experience and training, identifying hazards and correcting them. He's also one who determines if it's safe to work. He also, in turn, trains workers and will select the qualified workers, for example, to set the staging up, set the scaffolding up, or take it down, as the case may be. It's probably just as hazardous taking it down as it is setting it up, if not perhaps more so. Scaffolds should be inspected on a regular basis. And again, that inspection is done by a competent person, hopefully at the beginning of each shift, or at least on a regular basis. And if any parts are found to be defective, then they must be repaired, obviously, immediately. In this particular photograph, we see a deformed bearer. The bearer is the horizontal portion of the scaffold that supports the plank, so it looks to me as though somebody came along and sort of fixed it temporarily, but that certainly is not a permanent solution to that problem. That should either be discarded or professionally fixed. Scaffold erection, slide 41. Again, competent person. Competent person is a big thing in scaffold erection. Let's see here. Slide 42, training requirements. Training by a competent person on scaffold hazards, how to identify them, procedures to control those hazards. The training has to include, you know, the four big hazards: falling objects, electrical, proper use, and proper scaffold load. For example, the case I have in New Jersey where the gentleman fell, the scaffold was actually made from lumber that was found on the job site. And that's fine if it's built properly. But I could tell very, very clearly, just by looking at the photographs, and they weren't very good photographs either. I mean, the first thing I noticed when I received the information on this case, and I started looking at the photographs, first thing that went through my mind is, well, no wonder it collapsed. And this gentleman was killed. He was putting the window in, and the scaffolding failed. So the amount of load that a scaffold is capable of holding is obviously critical, as is training. If that gentleman were properly trained, then he may still be alive today. These are the guys that are actually putting the scaffolding up, and they have to be trained in the erection disassembling, moving, et cetera, and the inspection of a scaffold as they're erecting it, be able to recognize hazards and the proper procedures to use to correct them. Slide 44. Again, avoiding the main hazards of scaffolds, falling, bad planks, collapse because it's not been set up to support the load that is placed upon it, getting hit by falling objects, and again, electrocution. I have a case in New Hampshire. A gentleman was working on a metal building too close to the power lines, and he was holding one end of a very long piece of sheet metal roofing, and a gust of wind came along, and he maintained, he kept his hands on the metal roofing, and the other end of it blew into an unsheathed power line, and he was electrocuted. It came in his left arm and out his right arm, and literally blew his right forearm off. And it happens so quickly. You don't want to get near electricity, trust me. So that's about it. Summarization, proper scaffold construction methods, proper access to the scaffold, and the use of a competent person, not only in the erection but also in the use of and the relocation of scaffolding, training employees, inspecting it, and so on. And I think that's it, Matt. Slide 45.
Great, David, and I think it worked out very well. I was able to follow along just fine. Thank you for your cues, and I think it was a great presentation. We do have a couple questions here in the queue, and I'll start with the question submitted by Stephen, who had his first question answered, but he submitted a second one who asked, who is supposed to inspect scaffolds before they are dismantled?
Inspect the scaffolds before they're dismantled?
Yes.
That is a good question. It would depend on the height of the scaffold. As I said earlier, and I'll have to check this, and I'll make a note of this question, and if I have to find the answer and get back to you, Matt, then you can certainly forward my answer to Stephen. But as I said earlier, if the scaffolding is erected at a certain height, then it does have to be designed by an engineer. And I believe off the top of my head that it's 4 stories, anything above 4 stories. But to answer the question, again, it would fall upon the competent person to make sure that the people who are dismantling the scaffolds are doing it safely, and I guess I'm not sure what the purpose of inspecting the scaffolding when you're taking it down. Obviously, the purpose of inspecting the scaffolding as you're erecting it is so that you can make sure that it's free of defects. But I suppose inspecting the scaffolding as you're taking it down would be something that you'd want to do. I've never had that question asked of me before, but I think it would fall upon the designated competent person on the construction site. Okay,
great. We now have a question from Claudia, who asks, in the photo of the bricklayer scaffold, which I'm putting up on the screen now, which surface do the workers stand on when working? The narrow ledge near the wall below the wide surface, or the whole wide surface?
Okay, let me get to which slide number are we talking about here, Matt?
She's talking about the bricklayer scaffold, which I take as slide 38, I believe.
Right, toward the end of the presentation. for the overhand bricklaying. If you look at slide 38, which I assume you've got on the screen now, the wider section that's a little higher up holds people and building materials. The lower section that's up against the building is what they're standing on when they're actually working. I'm assuming that that's what she means, what you mean. Or
yeah, I'm asking her clarification at this point. While we get clarification, we do have a question here from Steve, who asks, if a drywaller is on scaffold over an open stairwell, does OSHA require a cover over the hole? If so, who is responsible for installing the cover, i.e. the drywaller, the general contractor, the carpenter sub, etc.?
That's a good question, because that is definitely a hazard. I've worked on so many residential construction sites, and that is a very good question. Stairwells are tough. They're tough to set up scaffolding in. Who's responsible for covering up the hole? Under OSHA regulations, the prime contractor holds responsibility for basically everything that's being done. And I'm going to make a note of this question as well. OSHA has a definition of prime contractor, which would typically be the general contractor. But also, if the drywaller is working for a drywall contractor, then the drywall contractor is obligated to make sure that his or her employees are working safely. It's also up to the employee himself to make sure that he's working safely and to identify hazards. The way that's done is by being properly trained and just using common sense. So I'm trying to envision the stairwell in my head, and typically if there are no stairs in the stairwell, in other words, what we'll do is we'll put in temporary stairs, usually made out of wood, that go where the permanent stairs are going to be when the house is completed, or when the building is completed. So we'll use the temporary stairs until such time as the finished stairs go in, which is usually after the drywall. So the drywaller is working in a stairwell that is basically has temporary stairs set up in it. And there's various ways to set up scaffolding using ladders, usually ladder jacks, because you're usually setting up scaffolding that is from one level over an open area. So the planks that go, say, from the floor that have to span across that stairwell so you can stand on it are usually going to be set up on a ladder that is leaning up against the wall within the stairwell. Each situation is different, but I think to answer the question, it's the drywall contractor and the general contractor who are responsible ultimately for the safety of the job site. And on residential construction, this kind of thing happens all the time. I mean, nobody's watching, as opposed to commercial construction, where they have safety personnel, safety manuals. A lot of residential contractors, you know, as I said, they send their guys out and assume nothing's going to happen. But all too often it does. I had a situation just like that in New Hampshire, I think, where a drywaller fell. Not sure if I got the case, but I know there was an inquiry about this, and it was in a stairwell in a house that was in the process of being completed. And, you know, you're looking at easily, you know, 14, 18 feet, sometimes 20 feet. I mean, 20 feet there is the same as 20 feet anywhere else. So residential construction sites can be, in many ways, more hazardous than commercial for that reason.
Okay, great. Thank you. I don't see any other questions in the queue. So we're going to wrap things up here. I want to thank David for doing a great job without the visuals in front of him. I thought the presentation went very well, and we got some comments from attendees who have been very complimentary of the presentation. So thank you, David, for your time and your patience and all the effort you put into this presentation.
Absolutely. Thank you. And thanks for joining us today, everybody.
Yeah. If you would like to speak to David about a case or project that you have, you can contact us here at TASA. Our telephone number is on the screen, 800-523-2319. We will be sending out a link to the archive recording of this webinar tomorrow morning. The archive recording will also be placed in the Knowledge Center on TASA's website. I've posted the link on your screen. Go to the home page and click on Knowledge Center. You'll see a link for webinars, and you can find all of our webinars there. And finally, if you have any follow-up questions or comments, please feel free to email me at mhyde@tasanet.com. We do take everyone's comments under consideration, and they help us improve our programs. So please feel free to send me an email on how these programs can be improved, or if you have suggestions for possible subjects. You will be receiving an email from me today at 3:30 p.m. that will thank you for attending. That will contain all of my contact information. If you need to get in touch with me, please feel free to do so. And like I said, we'll be sending out the archive recording as well as the PowerPoint presentation that was used during today's program in an email tomorrow morning. So on behalf of David and the entire TASA team, I wish to thank you for taking time out of your day to spend with us. Thank you again.